let's continue with our JiTickLogic library. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episodes, we added our Blackboard, we added our tree, we added our start node and the implementation for any node. And now we need to go on and add many nodes one after another until we finish every type of node that we have. The very first node that I want to talk about is the action node. Now, action nodes are just responsible of executing some code, and if the code was successful, then they return success. If the code was not successful, then they will fail. An example of action node is a node that will increase your progress by 1. So in the code, we have progress plus plus semicolon. That can be an action node by itself, and that's it. So we have a modular node that will increase our progress. Or another one would be a reset progress. So reset progress would say that, hey, progress equals 0, max progress equals 0, and that's it. It will return success. That is an action node. However, an action node actually can become really complex. For example, if you want to assign a recipe ID to your Blackboard on the tree so that other nodes will check it and do what they want, that is more than a single line of code. Actually, you want to see if the recipe ID is empty or not. Then if it's not empty, you will fail. If it is empty, then you want to go and take a look at the recipe manager, get a special type of recipe. If you were successful, you will set the Blackboard and return success. If you couldn't get the recipe, you will fail. And there are a little bit of complex logic there. So bottom line is that action node is one of the most used nodes inside your logic tree, because anytime that you want to do something, you need a type of action node. Actually, if we take a look at here, for example, a repeat would be a type of action node. But in many other places, as you see at the end of each subtree or any branch of a tree, one way or another, we have action nodes, okay? And this until success or until fail is again another action node. So you will use this thing a lot. And I'm telling you, a lot. If you take a look at here, let's say that these are action nodes. This is an action node. This is an action node. Then at the end of subtree, we will have multiple action nodes. This is an action node. And as you see, at the end of each branch, one way or another, we are ending with action node. So let's implement that node because it's the most useful node. I will not add it inside. Actually, this logic package, I was thinking about adding the logic that we want inside Minecraft directly, and I may keep it that way. So let's add it under nodes, Java class, and this is called action node. As we talked, if I open the start node, this section will be repetitive, so action node. And again, each node will have a Blackboard of itself, but we will ignore that one right now. So here it says implement methods, the tick. Before we go into the tick, we want a private final supplier of tick status, and we call it action. Then we need a constructor that accepts none of these two actually. Let's say that one, the action supplier, and we say that supplier tick status action, this dot action equals action. And finally, inside our tick, we will start a try catch section. Inside the try, we will return the action.get. That's all to it. And if we fail, now let me think about it. I have the logger here, isn't it? Yeah, as the dependency. So I can say that I want a logger. However, if each node will create its own logger, that's something that I don't like. So if we take a look at G-reference here, it has a logger somewhere. I hope so. Oh no, glogger is a direct class. So let's go into our main and take a look. This is how we are assigning a logger, okay? So coming back, we will say that at the very least, each tick tree will have its own logger. Now, problem is that when we go into the subtree node, let me take a look. Yeah, subtree nodes will have a child, an attribute as a tree, and that will carry its own logger. That's the only thing that I can do, because guess what? We don't have an entry main class for our logic tree, and we can't have some something like that because this is a library, okay? So here, all I can do is say JiTickLogic as the mod ID, and I will have that. So let's call it logger. And here we say public, actually I can say get logger. And inside the node class, I can say get logger public that returns a glogger, and we call it get logger. And this one will say this.tree.get logger, and we return that. So now inside our action node, when we fail, we can say get logger.log error, and here the message is error evaluating action plus e.message, and at the end we return tick status.failure, and that's it. As you notice, we are not directly returning success here because this action is accepting a supplier of tick status. This means that, for example, in any mod, we can say that we are adding a supplier of something. For example, we say progress plus plus, and then at the end we say return tick status.success. And this will work. However, right now it will fail because it says that defer assignment to action using temp variable. So we need to put it inside a variable. But when we are calling this constructor, we can directly send in this lambda. And this is actually the action that we want to do. You see that we are increasing the progress and then we return success. And that's it. So we can do that in any implementation of action node that we want inside our mod. Believe it or not, that's it. This is the most used node inside your behavior tree. Already done, already finished. So let's go for the next node because it's almost identical with a little bit of difference, and that is the condition node. Now, condition node is just like if statement inside your tick method. Anytime that you are using if, you can use a condition node. However, there is no else. So if the if condition is failing, it's failing. So you need to be careful about using this one, okay? We can think about an if-else statement like this. Let's say that if I add a selector and I have two conditions, okay? 1, 2. This is the if statement. Now we know that selector will go to the next node if the first one is failing. So basically, this is if and this is else if. However, if we delete this node and put an action node here, this will become else. So we say if this condition, then we want to do something, else this. However, this will not work. So when we want this, we will have a sequence and then an action here. So we are checking a condition here. And if the condition returns true, then we want to do something, okay? And this is the body of your if condition. It can be a single action, it can be a sequence, it can be anything else. However, if this condition fails, here, it will become failure for the sequence and the selector will go for the next branch. Now this will become the body of else. If you want else if, again, you will do this thing here. So this will become another if statement. If it's success, then it will do something else. And at the end, again, you may want the else statement at the end. So that is how you will design your behavior tree using the condition node when it comes to if statements and else if and else statements. Now keep in mind, the behavior tree is really powerful. So if the condition is failing, the next node can be a sequence, a selector, a parallel, a random selector, a random sequence, or a subtree, or anything else. So you can do anything that you want design-wise, and you're having complete freedom. However, a condition node is not having a body to execute anything. It's just the if line. So if something is greater than something, that's it. That's the condition node. So again, we need to implement the tick method. But before the tick method, here we want a private supplier. Now this time we are going for a Boolean, okay? Import class, import that, and we call it condition. And then we need constructor that accepts the supplier. Inside the tick logic, we will do this. We will say a try and then the catch e. The catch is almost identical to this guy. However, instead of action, we will say condition. And this time, I'm assuming that if the condition was not correct and we couldn't get the supplier of a Boolean, we will fail the node. Some implementations may want to have error here, but I didn't implement error. I will add the error here because I think it's useful in both cases actually here. We want to send error error, because if something is failing, then the whole logic is failing, and we want to be aware of that error, maybe through an exception, I don't know, or maybe do something otherwise. So inside our enumeration, tick status, success, failure, continue, stop running, and then error. Of course, it will not work because I need to update my Maven local and then, do everything on reloading and resyncing my program. However, we know that it's there, it will work. So inside the try, we will say if condition.get. This is like executing the if condition. So if the condition returns true, we want to return tick status.success, and else we want to return failure. And this is why I'm not returning failure here, because if we fail a node, a condition node, what is the reason we fail? Did the check failed, or did we assign a lambda totally wrong? If the lambda is wrong, then we are error state, not the failure state. If the lambda is correct, then the condition simply not met and it will return failure. Okay, that's our condition node. And honestly, I could add another method here, but because we keep it as final, what I'm thinking about is that I can have public void set action that accepts that, and all we are doing here, we say that this dot action equals action. However, this will fail because it's final. So let's remove that final. It gives a little bit of flexibility in your tick logic. For example, in your tick logic, you may want to check a condition, and if some condition is met, then the action will be something. If it was failed, then the action is something else. That's not classic behavior, but I will add it here anyway. So here I didn't add the final, so I will say set action, set condition actually, and now we can have a condition. And believe it or not, again, the second node is already done and finished and ready to be used. The next nodes need a little bit of explanation, although I had done it in many places, but I want to stop here and make sure that you will understand each and every node as we progress forward.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.